commercial airplanes. And what you see here is a 30-foot-long test article that we'll be testing at the NASA Langley Research Center by applying the kinds of loading that it would feel if it were in a real airplane.
But with a piece this large, a major hurdle lay in front of them: how to get the piece from California to Virginia for testing. Traditional methods like trucking and train travel would not work due to bridges, overpasses, and some roadway restrictions. The solution was to fly it across country. But no ordinary aircraft would do. Ultimately, the team enlisted the service of NASA Johnson's Super Guppy aircraft for transport across country. This Cold War-era aircraft was specially designed with a hinged front-loading system that could just barely accommodate NASA's cargo. It was not lost on team members that this old and slow beast of an aircraft was transporting a test article that will undoubtedly be used in many aircraft of the future. On a cold December night, the aircraft landed in Virginia for an early morning offload. Here is Dr. Faye Collier to explain what is next for this test.
Today we're here at Langley Field unloading the Perseus multi-bay Colts multi-bay box that will be tested in the Colts facility. So we've been working on Perseus for about 10 years now, partnered with the Air Force, partnered with Boeing, R&T, and we started off with small coupon testing to prove out the concept. We built a small box that we tested 3 years ago to prove that the concept could take pressure and would meet the design constraints. We went from there to assembling this piece of 30-foot structure that we're going to test in the Langley Combined Loads Test System down the street here. So a long effort that has gone into this with NASA and Boeing, culminating in the delivery of this 10,000-pound piece of aircraft structure. We'll stick it into the facility. We'll mount it. It'll be eventually pressurized to various pressure readings. The idea is to twist and turn the part to see if it'll sustain the design loads that would be needed if we were to build a real airplane out of this.
This facility will prove to be a valuable tool for researchers. These types of tests will help in investigating damage tolerance and any repair techniques that may be applicable. One of the key test points that will be addressed in this round of testing will see how Perseus handles routine damage that might be expected, such as a technician dropping a hammer. Researchers need to understand how this new material will react if minor damage occurs. To do this, a unique test rig has been designed by hand. Here is Andrew Lovejoy to explain.
So some of the things that could impact the plane are rocks or debris that's on the runway when it's taking off or landing. As I said, you could have mechanics that could hit it with a tool, or a vehicle driving by could hit it. And all of those types of things can cause damage. And on the exterior, you're more likely to have a higher energy because a vehicle hitting it or something being thrown up by the tire is going to be a much higher velocity than, say, a tool drop. So barely visible impact, if you're doing walk-around inspection, it's a damage that you would barely be able to see. So if you're at that level, the aircraft has to be able to sustain the loads that it would normally